Hey everyone, hope you're having a good evening. As it looks like we can't fit any more people on the stream, I guess we'll get started. So today's talk is going to be getting started with Windows malware development. My name's Rad, and let's talk a bit about who am I. So I'm a senior security engineer for work, but outside of work and a bit at work, I'm a passionate malware developer. I love all things malware related. And I just love writing like different proof of concepts and various malware for Windows. And Windows has just kind of become my hobby and my passion. Along with that, I'm a Black Mass Volume 1 contributor, which is a small little book that VX Underground released a couple months ago. It's got some other great articles by some really cool people. I highly recommend checking that out and staying in tune for the second volume, which is coming out soon. So, what are the motivations for this talks? A lot of people, when I made this Discord server, were messaging me. They were asking me, where do I get started? And so I didn't. I started a while ago, and if I had a resource or a list of things that I could have had when I got started, this is just kind of what I would have wanted. I didn't want to make this a too technical talk. I wanted this to be a high level overview where you could potentially provide a path for you to teach yourself. And there's a proverb I quite like. It's called as you can read it on the screen. If you give a man a fish, you feed him for a day. If you teach a man to fish, you feed him for a lifetime. So my intentions of this talk are perhaps to provide the bases or like the starting grounds for you to quickly progress your malware development career or your experience. And to do this, I provide a high-level overview and a mental model which I have found useful when approaching new problems and situations. So let's get to it. Let's get right into it. The first step I think is that's most important for learning malware development is learning to program. As we all know, malware is just malicious software. It's in the name, malware, malicious software, and to have good malware, to be a good malware author, you've got to be a good software author. And often or not, on engagements, we want our malware to blend in as legitimate software. What easier way to do that than using the same languages that are used for legitimate software? There are very many various programming languages, and there are different use cases for each. I'm not one to argue about which programming language is better than the other. I think the most important thing to do is identify your goal and pick the most suitable language to achieve that goal. And when it comes to programming languages, as far as it goes for the implant, there are a number of languages, of course. On Windows, there are like four main languages, which I typically see malware written in. Of course, there are other more niche languages such as NIM and whatnot. But I think as far as getting starting goes, I think C is the most important language to learn. A book that I would personally recommend is this has taught me countless things, and I typically see myself going back to this book to reread chapters I find important. Was C, a software engineer's approach, a software engineering approach. And I think it's important to, if you already learned a language, that's fine. But if you don't know C yet, I think to be successful in malware development on Windows, knowing C is critical. It's like you just need to know it. Of course, I'm not saying C is better than another language. I'm not saying C is better than Rust or whatnot. But I think it's critical to understand the fundamentals with C. Once you've learned C, it's good to learn other languages, like potentially you can go learn C++ or Golang or Rust. As far as resources go for them, Effective Modern C++ by Scott Myers has been a great book. It's a book that a friend recommended to me, and it's taken me far, and I've really enjoyed it. When I learned Golang, I felt that was a language I could learn better through examples, and Go by Examples, I think it's a free website, and you can check all the examples there. And as far as Rust goes, the Rust community has published endless amounts of resources for learning. The Rust programming language is one that I used and I found invaluable. And I thought that was good. And as far as writing your backend goes, pretty much anything works. Use whatever you're most comfortable in, or whatever you think is good. There are many C2 backends, or well, command and control backends written in a number of languages. So you've got Golang, Rust, C++, Python. Typically, I'd like to write mine in Python or Rust, as that's what I prefer. But I think fundamentally, language wars are pointless. The people who typically are arguing about what language is better than other don't have enough time to write in those languages. So I just use what works, and the languages I provide are just examples. You can pick what you want to do. So I didn't include, for example, C Sharp. C Sharp is a very popular language for writing malware, and you've got a lot of malware written in C Sharp. And fundamentally, your goal at the end of this talk, and when you go beyond, your final goal, well, would be to be comfortable with reading and writing multiple languages, as when you don't want to be limited by your knowledge of knowing, for example, two languages in relation to the implants that you can write. You want to be able to pick up languages quickly. For example, if you want to write a browser extension, just because you know C, that shouldn't limit you from writing the browser extension. You should try be able to pick up the relevant languages pretty quickly. Once you know how to program, I think it's only natural to start developing a basic understanding of assembly. There's a great book that I've read and I've seen referenced in. It's typically a book that you'll see in university. It's not exactly for Windows, it's more for Linux, and there's various things you don't really need to know that are related to Windows, but I think it's a good book to have nevertheless. It's called Computer Systems, A Programmer's Perspective. They've got some nice assembly challenges in the book and whatnot. And another OST2 have released a great course. I cannot recommend it enough. Arch 1001. It's got a bunch of cool tutorials and games within the course that really just help build your understanding. Zeno, the guy who gave the course, he's got some really funny jokes, and I think that's like probably my best number one resource to go learn assembly and basic system internals. Once you've gone through that course and once you've learned C, being able to put your code into, for example, Compiler Explorer and see what the associated function looks like in assembly is invaluable. And you may be asking, why would you even learn assembly? So for an example use case is in the Havoc framework by Spider, as I'm sure many of you are aware, he uses it for indirect syscalls, which is probably something you're unaware of, but it's an evasion technique to avoid userland hooks and call stack spoofing. And for the primary content of these use cases, he uses assembly. And once you've got a basic understanding of assembly, I think it's quite important to get used to with debugging with WinDebug or x64 debugger. Again, OST2 has another resource for another course for learning how to use WinDebug. I highly recommend checking it out. There's I think they've got fundamentally, I think you should just go check out OST2. It's a great resource. It's a great place, and it's amazing. And so your goals after you learn assembly, your high level goals would be comfortable with reading both Intel and AT&T syntax instructions. And the second goal would be comfortable with debugging code with and without symbols or the source code. The step 3, once you've got through assembly, once you've got through programming, now we're actually moving on to the core of Windows internals. And my primary recommendation for getting started at least with Windows internals, would be the first 3 chapters of the Windows internals book. It's quite a dry book. That's known. I wouldn't recommend going beyond the 3rd chapter. I mean, as to read it back to back. I'd probably just use it as a reference material. And the first 3 chapters will provide you with a solid understanding of memory, threading, processes, and that's kind of like the key information you need to know to get started. I think having a strong fundamental understanding of Windows will definitely help when you start using, like, for example, the associated APIs, to understanding what those APIs do. Another thing that I found really useful for me when reading Windows internals is, for example, if there's a function about memory allocation, I'd go look at the React OS source code and try find what functions are responsible for this. The React OS source code is essentially like a 32-bit reverse engineered reimplementation of Windows. It's a bit outdated, but I found it's still very useful. And on a day-to-day basis, I always find myself looking at React OS source code while I'm reverse engineering. Again, just follow through the exercises in Windows internals. Make sure you understand the key points. You want to be able to answer any system internal questions that you have, and again, reverse engineer which system components are interesting to you. I know I don't really provide much information on how to get started with reverse engineering. I just say get whichever associated DLL you're interested in, put in Ghidra, make sure the symbols are loaded, and just look at the pseudocode, and just you'll have fun. You'll be able to get it. Just make sure you're able to teach yourself how you want to answer specific questions. So the kind of goal that you're looking to achieve here is being able to understand how to answer Windows internal specific questions. So if you have a question like how does X do Y, you want to be able to know where to look and how to actually answer your question. And that's helped me several times when creating, for example, an evasive proof of concept, and I don't understand why this is doing that. Or if I see reverse engineering an implant and I see it doing something interesting, being able to understand why it's doing that something interesting and being able to know where to look to answer that question is critical. So, for example, this was a function I was looking for. I wanted to understand what this function was actually doing it. So the two ways I could have approached that was either reverse engineering the associated DLL that this function is implemented in, or just looking up against React OS and looking at the source code, which is not exactly the same, but it's similar enough where I have a good understanding of what's going on. The fourth step, which has been incredibly useful for me, is read leaked malware source code. So there's plenty of times you'll see disgruntled employees of, for example, Conti or whatnot, or you'll see those source codes being posted on the internet, and you want to be able to look at that source code, start at the entry point, and be able to answer some specific questions like what is being performed and why is it being performed, and you want to go through the source code and slowly understand. What's invaluable about these leaked source codes is that these were used on real engagements against real companies, which I don't endorse. However, being able to learn why they're doing this is invaluable because they really have typically one goal, which is financial gain. So their code typically does work. So it's good to look at a working example. And when you look through this code, you want to see, if you identify the usage of functions, you want to see, is there another way to perform the same behavior of these functions? And one way to do this would be to see if it's a high level function, for example, something implemented in kernel 32. Does that call down into something implemented in NTDLL? Is there another way to call the same function being used? Haven't seen an API used before? No worries. I'm always in the same boat. When that happens, I typically just search. I use this Google Doc to just identify references to this function on the Microsoft website. So I'd search site https learnmicrosoft.com NT-allocate virtual memory, and then I'd get a bunch of results. I'd just look through the documentation, and that's very important. You want to look through the documentation whenever you see a function that you're not used to, because those functions, understanding the arguments passed to them and the return value and kind of giving it some context helps reason why that function is being called and why it's maybe useful to you later on. So some good starting points for looking at leaked malware source code. VX Underground, of course, they're like the go-to place whenever for anything malware related, so I recommend checking them out. Of course, they've got some great resources, great papers, and they're like the go-to place. So some of the samples I've looked at and source codes I've looked at and I've gained a lot of information and knowledge from are Zeus, Moivy, and Carbonac. Carbonac's quite old, and likewise with Zeus, whereas Moivy is quite recent. They all achieve similar or kind of similar but different things, and being able to read through these source codes, they're massive, they're very big projects, but being able to read through them and understand what's going on and why they're doing these certain behaviors is great. And I typically have found myself getting new ideas when reading through these codes, because these guys have had to solve very niche problems in different ways, and the ways they've achieved it have worked. The source code, I mean, when you download these repositories, sometimes they may have documentation in it. It will typically be in Russian because a lot of these developers are from Russia. I just chuck into Google Translate just to understand the comments, and that actually gives a lot of context. And being comfortable reading various malware source code and reasoning with the code is kind of the goal for this. So if you're looking at this, once you've learned your C, once you've learned your basic Windows internals, I want you to come to, for example, Zeus. I want you to look at the Zeus source code and understand why it's doing certain things. Zeus is an incredibly complex piece of malware for its time. When it was leaked, it was like wow, and like some really cool forks came of it, and likewise with Carbonac and Moivy. So being able to reason with these source codes, I think, will really help you accelerate your progress as a malware developer, and I think that's invaluable. Resources, as I said before, VX Underground is amazing. Like I learned an incredible amount from VX Underground, and kind of the way that I'd approach it is I'd look through their Windows HTML index. I'd find a paper that that looked interesting to me, so as such I had the motivation. I'd then if it had a paper associated with it, I'd read through the paper. I'd Google whichever words I didn't understand. Slowly by slowly, I'd make my way through the paper, understanding why and what is going on. I'd understand and identify the goal of any associated code with that project. And then if there was code, I'd try compile and debug it and see if there are other ways I can achieve the same goal for with different code, with different APIs. And some other great blog posts. So Modex, he's got an amazing number of amazing blog posts, and you should check out his GitHub repository. They're top notch. Likewise with x86 Matthew, his blog posts are amazing. His source code is really clean. It's easy to understand. I recommend checking out his code. Some other malware blog posts are Preempt. I think the guys who are behind that, there's some really friendly guys. If you've got any questions, just send them a message. I'm sure they'll be happy to answer. And as far as GitHub repositories go, I think they're two really important and well-written and well-documented repositories. So you've got Stephen Fewer's reflective DLL injection. That's the first one. And secondly, Rapid7's Meterpreter source code. I think if you have like Meterpreter's almost done it all. Like they've got extensive documentation. Their code base is massive, and it's you can just get endless ideas just from reading the source code. It's really well architectured and engineered. On the other hand, a resource which I have found useful in understanding how blue teams and reverse engineers approach malware is by watching OA Labs' stream. He's a great reverse engineer, and he streams quite often. I recommend watching his streams, watching his stream, which is on Twitch, joining his Discord perhaps, and watching his videos on YouTube, which he reverse engineers, for example, ransomware samples and whatnot. A mental model which I have found invaluable for me is understanding that the map is not the territory. And while maps represent reality, well, okay, I must have made a typo on my first line there. Maps don't actually often represent reality. So just because a map says something, it doesn't mean that's actually the case. So well, MSDN represents reality. What is real is often different. Yeah, don't blindly trust what's on the map. Don't blindly trust the documentation. For example, MSDN misses out a lot of stuff for example, that's undocumented. So the territory is beyond the map. So I insist and implore you to go explore the territory, and you'll realize that there are things beyond it. And actually look what's happening and trust but verify yourself to make sure what you're reading is actually true. Of course, you may not have all that time, and there are times where you just have to just take it with a pinch of salt. But don't blatantly trust documentation, because documentation many times can be wrong. Um, One of the most important things to do is ask better questions. If I had known 2 years ago how to ask better questions, I can only imagine that I'd have accelerated at a better, faster pace. Being able to ask what questions and ask a better question to get a better answer is invaluable. Um, a friend told me, first actually understand what you're trying to solve and understand the goal of what you're trying to achieve, and then ask a question, and what question which gets you from the problem to the goal. A quote I like from a business book I read is, whoever best describes the problem is the one most likely to solve it. Of course, in the problem of a question, whoever best describes a problem in a form of a question, maybe to yourself or to other people, is great. And is on the topic of questions, that brings us on to our last slide. Does anybody have any questions? If you go to the talks bar, there's a little chat icon. If you just click open chat, you're free to feel free to ask any questions, and I will send these slides along. This was a very high level overview, but my aim was to teach you to teach yourself. I'm self-taught. I taught myself along with the help of many others, so I cannot claim that I stand merely on the shoulders of others. But being able to teach yourself and answer these important questions yourself is invaluable. And so the first question is, have you done the Game Hacking Bible on guided hacking? If so, how has it complemented your abilities in malware development? No, I have not done the Game Hacking Bible on guided hacking. I've seen some of the content on guided hacking. I think it's alright. I think the goals for game hacking and malware development are different. Game hacking, of course, is much more technically advanced than malware development, but to say that we kind of have different goals of what we're trying to achieve, so I don't think it may help you, but I don't think that's something that's really comparable. Okay, so we've got a question about courses. Is it worth spending time on malware dev courses like Sector 7 multi-level courses? Well, I haven't myself done the Sector 7 courses. I think Sector 7 is a great resource, and I can only recommend you check it out. The problem with courses, courses in my opinion, is that they kind of spoon feed you and they don't teach you to learn the hard way. And if you have that time, I think being able to dedicate it to learning and exploring the territory is invaluable. Whereas with, like, for example, Sector 7, you get given a map and you're told this is what you can do, and you don't really see yourself exploring beyond that. And as far as other courses go, I'm not sure which other malware development courses there are out there. I think the best way and the most invaluable resources like VX Underground and the papers they have listed out there, they're going to take you a very long way if you can just sit through those papers, read them, and actually have put some effort into understanding them. So next we have, how important would you say is having the blue team perspective for writing malware? So I'm not much of a blue team. I've done purple teams in my past. I think being able to reverse engineer is more important for blue teamers, but being able to reason why malware developers are doing specific malicious things are useful. Being able to understand why, and that's something that blue teamers may be able to pick up when writing malware that they may not have been able to without. I hope that answers your question. Suppose an EDR detects you somehow at one point, for instance, when you do privilege escalation or something like that. How do you approach the situation? What is your thought process to find a new way to bypass the EDR? Do you reverse pieces of it or what? Well, that's kind of out of scope for this talk, but I'm sure I can dive into that. So if I'm detected by a specific EDR and I have access to that EDR, my first things would be replicate the behavior which got me detected in a lab under a controlled environment. And if it is detected, well, then you'll get a notification on the EDR dashboard. And if that's the case, then I'll go have a look at what the notification is and see if that discloses any information. Then I'll try to understand what the behavior is. I'd probably narrow down how much activity I'm doing into lesser and lesser API calls to understand what actually is triggering it, and at that point I'd once I've identified what API call is what specific behavior is triggering that, I'd go start performing reverse engineering, or I'd see if there are other ways to perform that same behavior. Can you recommend to get a grasp of basic reversing apart from what can you recommend to get a grasp of basic reversing apart from the ASMC resources you pointed out? I think just reversing stuff, just taking like a random piece of random malware sample, random DLL, and just reversing it. I think there's nothing else that I'd recommend. I think some more people. I'm not like the best reverse engineer there is out there. I just reverse engineer to get things done. Yeah, I think just doing it. I think there's no substitute for that. What the hard way looks like in Maldev. Sorry, I don't quite understand that question. What is the worst EDR you've come up against? I think that's not something I can objectively say. Different EDRs do different things. They're all quite similar, but they've all got their pros and cons. I don't think I could say one EDR is better than another, or one EDR is worse than another. And worst by worst, I think you could either mean very hard for me to evade, or very hard for me not to evade. What was the first piece of malware you made? Oh, just a simple shellcode runner. Are there any other questions? Any tips on Linux malware devs trying to learn Windows malware dev? Well, this probably isn't my area of expertise, but I can try to answer it for sure. So Linux definitely has some things that are similar, but again, it has some things that are very different. So different formats, different structures, different way the whole the system architecture is completely different. So I think just skipping ahead to understanding like the Windows internals, so just reading through the first 3 chapters of Windows internals to kind of grasp the system architecture of Windows will probably help you see the similarities and differences between Linux and Windows, and that's probably where I'd start. Hopefully, I'll probably be able to put a better answer for you after this talk. And I think that's something I could try. What was jail like? Fortunately, I haven't gone to jail yet because I haven't committed any criminal offences. What has been the most exciting moment in your career so far? I don't believe that that's relevant to this talk, but for sure, I'm happy to go into that. So, I had a phishing engagement where I got a number of callbacks from a malware I crafted, and I thought that was pretty fun. What resources would you recommend for learning code virtualization obfuscation? Sure. So there's a book called Surreptitious Software by Christian Kohlberg, and one second, I'll just type it. Tigris uh, .wtf. I recommend just checking out that website and looking at the content on that website. Um, will there be any more cool talks like these or low-level ones? I'd like to, as again, this talk was quite high level. I was looking to set the stage and just kind of introduce it. I think yeah, we're gonna try to have more talks. If anybody does want to do a talk, just send me a DM with your talk title, your abstract, and when you think you'd be ready. Um, I think it's nice to have low-level talks, and there's some people who'd like to do low-level talks that I'd love to have on. So I think that low-level talks always take priority, but it's always good to have high-level talks, and I'm happy to host any talks related to malware. How do you build an EDR lab? Sure. So this is definitely something for another time. But for example, MDE and Elastic both offer quite easy ways to get subscribed. Um, you can use either of those. The way I'd recommend it is just having two VMs, one online, one offline, both with the EDR installed. You run your, depending on how you want to approach it, you can run your malware sample on the offline machine. If it does get detected, where you can just revert it back to a previous instance before by taking a snapshot, as to avoid uploading it to the cloud. And then every now and then allowing the VM to be accessible to the internet to update itself to get new detections, and that's typically the way I'd approach it. It depends what you're trying to test against that EDR. For example, if you're looking to test lateral movement techniques, you need to build more than just more than just a single machine. Is it possible to get a totally remote job after learning malware dev? Potentially, there are legal jobs, and I know there are jobs out there for malware dev, but it's not typically just malware development. You may be doing consultancy and red teaming as well. Do I write malware as part of my job? Um, Partly, it's not kind of my main focus. My previous job, I did do a lot of that, and that was really fun. Yeah, Tigris is for Linux. You can just because the concept of virtualization can be um, translated from Linux to Windows quite easily, just because the concepts still remain the same. They aren't really that different between operating systems as far as virtualization goes. Um, it's not that important to learn kernel development from the start. It's okay to understand the fundamentals, but for me, just understanding the fundamentals and being able to reverse engineer specific drivers I see or mini filters I see EDRs using, and my fundamental knowledge, and just being able to Google, as I said before, being able to Google functions I didn't understand is great. And we can see junior pen tester heckling me. Um, how long did it take for you to become comfortable with mal development after learning programming to a certain level? I couldn't really put a time on it. I think once I understood C, it was almost a seamless transition. Like my memories are just one another with each other. Once I understood C, I felt like I could do anything. I felt like I conquered the world. It's seamless, exactly. Once, yeah. So I think once you understand C, and once you can actually you understand the fundamentals. So the first couple points I made, I think it will help you progress quickly. And once you start reading through malware source codes, that was a great thing for me as well. Reading through the malware source code helped me understand actual real world implementations, and they helped me. For example, I would build um, agents based off the source code I read, and for example, like Moivy or Carbonac, and I'll just build like tiny, smaller agents with like source code pulled from that, and I just play around with it in the lab. I understand what it's doing, and just doing that, repeating that process, and just there's no substitute for hard work and time. So being able to put those hours in, being able to actually understand what's going on, that's invaluable. So yeah, does anyone else have any other questions? Most yeah, so the most impressive source I've looked at and learned from was it has to be Moivi. No, it's fine. It has to be Moivi. Moivi was a very cool piece of malware. It's a file infector, and it's taken me a good minute to. I still haven't fully understood it, but it's very 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 cool. And of course, don't go compiling malware and running it on your host system. If you're going to uh, compile and run malware or run malware at all, make sure you have a proper setup with your machine isolated from the internet in a virtual machine. But that's for another time, and I'm sure if anyone wants to know how to do that, you could just ask, and these guys definitely answer the question. What IDE do I use? So I don't have a preference to any one particular IDE. I use what's best for the language and for the job. At the moment, I'm using VS Code. Before, I've used Visual Studio, and I think it's a waste of time to argue about IDEs. I think, for example, I can't actually remember what other people IDEs other people use, but my favorite reverse engineering tool has to be IDA. I'm pressing F5 and just looking at like Windows components is just such a blissful experience. It's nothing like nothing like it in IDA. And on that note, I think if no one else has any questions, I think can we call it a day? Yes, this talk will be recorded. I'll post the slides as soon as I disconnect from the call. And yeah, thank you everyone for coming. I'm happy to have set the stage for talks here. If anyone would like to do a talk on any low-level malware-related topics, be sure to just send me a message. If you've got any questions regarding this talk that you aren't able to ask now that you can't think about later, just send me a message. I'll be happy to answer. And yeah, I'm happy for you guys coming along, and thank you for your time.